Hello everyone and welcome back to another episode of Math Unlocked. I'm your host, Mrs. Rhodes-Grierson. What are we doing today? Today we're looking at how do we find the length of a line segment. So we are not on the Cartesian plane today and we want to find the length of a line segment given its endpoint. What do I do? Well, first thing I'd like for you to do is to do a little sketch to see what would this line segment look like. Based on the endpoints that are given here, we know that A is at 2, 1, and if you recall how a coordinate operates, the first number here is your x value. So seeing that this is my starting point, I'm going to call this x1 and this y1. This is my ending point, so I'm going to call this x2 and this y2. Now how do we proceed? Let's give A some arbitrary starting point, seeing that we're not on the Cartesian plane. I'm putting A arbitrarily there, and I'm saying, where is B from A? Because I want to find out the length of the line segment AB. So if B is somewhere from A. Now, A is at 2, 1. B is at 8, 9. So from A, B being at 8, seeing that A would have started at 2, let's look at the horizontal first. The horizontal is this, how far? Since B is at 8, it would have been going that way. How many units? Starting at 2, going all the way to 6, to 8, and going 1, 2, 3, 4, 5, 6. Then it being at 9 on the vertical, started at 1, going up. I'm going to go 8 spaces up. 1, 2, 3, 4, 5, 6, 7, 8. So B is somewhere up here. Now remember that this is a sketch. We are visualizing what this should look like. So I'm going to connect it since it's the line segment connecting A to B. This is the distance that we're actually looking for. This is a slant line. Now, see that you just noted that I went horizontally. And when I went vertically, it means that where these two lines intersect would form a 90-degree angle right there. And that therefore means that this length that I'm looking for represents the hypotenuse of this right angle triangle. This would be my height and that would be my base. How do I find the distances here? Remember that B was at 8, 9 and A was at 2, 1. So the vertical distance here, horizontal distance here can be calculated because we can say what's the difference between the x values. So we would have looked at or x1 and or y1 down here, or x2 and or y2 up here. What's the difference here to find out the distance here? See that this starts at 2 and ends at 8 on the horizontal. We would say x2 minus x1, which is 8 minus 2, that gives me 6. Up here, this is my vertical rise, and looking at y2 minus y1, that's 9 minus 1, which gives me 8. So now I know what is my base and what is my height. I can now calculate the hypotenuse using Pythagoras theorem. Now you would have done trigonometry before if you're here. That means that you can apply Pythagoras theorem to find the length of AB, which is actually the hypotenuse of this right angle triangle that we've just formed. What do we do? So now applying Pythagoras theorem, that would have said AB squared is equal to, down here which is my base, 6 squared plus 8 squared. We're going to simplify them solve. 6 squared is 36 plus 8 squared is 64. That means AB squared would have been equal to 100. Simplifying that, we know that AB, to get the square from here transposing, we have to square root. So we're square rooting both sides. That means that the length of AB would have been 10. And that is how I find the length of a line segment if I have the two endpoints. Now notice the approach that I took was to do a little sketch to see what does it look like. Applying all of this to what you have learned prior to the little formula, this adds up to what that formula is. So let me remove some of well, let's not remove, but just to add. What the formula is that it says that the length of line segment AB would have been equal to the square root of x squared minus x2 minus x1 all squared, because we're applying Pythagoras theorem, plus y2 minus y1 all squared. How do we get to this? Remember that we're finding the distance of the horizontal distance here, which is the difference between the two x values. That will give us our base. The vertical distance here is the difference between the two y values, and that will give us our height. Pythagoras theorem says that the sum of the two sides, the two legs of the triangle, would be the square root of those sum of the two squares will be equivalent to the length of the hypotenuse, and that's how this little formula comes out here. And all of what we have done here is the application of this formula here to give us how to find the length of a line segment when we're given two endpoints of that line segment.